This is Cellular Respiration Part 2. We're ended with this location. We finished the Krebs cycle, and we're getting these electrons transferred to the electron transport chain. So I'll share how that works quickly. Electron transport chain, what you have delivered are your high energy electrons and your protons. As the electrons go from a high energy state to low energy state, kind of like turning water wheels. If you remember water wheels over creeks help grind grain. As it goes from high to low, it pumps hydrogen protons out of the inside of the mitochondria, the matrix. So you now have a buildup of hydrogen protons in this area here. The actual process of making ATP now is due to the high level of concentration here and low level of concentration here. These hydrogens will come through this ATP synthase, and that provides energy to phosphorylate ADP to form ATP, which is the energy source we're trying to form in the first place. So electrons, protons delivered. The electrons go down the energy source, pumping hydrogens up. The hydrogens flow down through a specialized gate. Result is we make ATP. And now what you have a high level of hydrogens inside here and their associated electrons. Of course, each of these form a hydrogen atom. And if these hydrogen atoms are continuing to build up here, you lose a concentration gradient for hydrogen. You stop having hydrogen moved, you stop making ATP. So you have to remove the hydrogens here for this process to continue. Thus, we inhale or breathe in O2, oxygen gas. Now you have H plus another H plus oxygen forms water. So the oxygen we breathe in joins with these to form water. Because the oxygen is called the final electron receptor. The first electron receptor, remember, was NAD. It received electrons and transferred them down to the electron transport chain. Thus, if we can't get oxygen, we cannot clear out the hydrogens here. We lose a gradient, this process stops working. Let me show you now in summary what you need to know on cellular respiration in class. We'll begin with glycolysis. The first step, you put in 2 molecules of ATP to get it going, the energy of activation, and of course a 6 molecule glucose. What you get out are 4 molecules of ATP and 4 hydrogen atoms. Now you get out 4, but since you have to put in 2, you'll have a net gain of 2. You also release pyruvic acid. Now pyruvic acid can go through some changes. First of all, there's no oxygen available. Then it goes to lactic acid pathway, fermentation pathway, and forms lactic acid. If oxygen is available, it goes through an alternative pathway, or a transitional pathway, and forms acetyl coenzyme A. Pyruvic acid 3 carbons, acetyl 2 carbons. We lost one of the carbons as gas, as CO2 gas during this step. Acetyl-CoA then enters into the Krebs cycle. So acetyl-CoA enzyme A enters the Krebs cycle. What's given off is your carbon dioxide, your hydrogens again, and ATP. Now this happens twice. You do it once per pyruvic acid, but you get 2 pyruvic acids per every glucose molecule. The final step is electron transport chain, where the NAD we talked about earlier will harvest hydrogens, electrons, and protons from glycolysis, harvest them from Krebs cycle, and release them at the electron transport chain. So you have the electrons and protons enter. We showed you how that worked with the water wheel analogy. We inhale oxygen, you have oxygen to electron transport chain. What you get out then is ATP, about 32 molecules, and water, which is formed as oxygen works as a final electron receptor for the hydrogens and the protons. So for the summary of what you need for glycolysis, know the 3 steps. Know for glycolysis, ATP and glucose go in, ATP and hydrogen leaves. The hydrogen is harvested by NAD. You also produce pyruvic acid. If no oxygen is available, you go the fermentation pathway to form lactic acid. If oxygen is available, you form acetyl-CoA through a transitional reaction and give off carbon dioxide. The acetyl-CoA now enters into the Krebs cycle. The result of the Krebs cycle is it gives off carbon dioxide, more hydrogens, which are harvested by the NAD, and 1 molecule of ATP. You get twice as much because you get this much for 1 acetyl-CoA, you get 2 because you got 2 pyruvic acids. For the electron transport chain, what goes into it are your hydrogen, protons, electrons, and oxygen. What you get out of it is your ATP and your water molecules. Quick time to review or go the alternative pathway of the lactic acid. You have pyruvic acid. If you relieve or drop off your NADH and drop this off and add it to this, you now have this structure. That's your lactic acid. So by simply dropping hydrogen off here, and of course there'll be 2 hydrogens you drop off. One binds here, one binds here. You get this structure, which is lactic acid. You will not need to know the exact chemical structure like this. You will need to know, obviously, that pyruvic acid will change to lactic acid in lack of oxygen, and pyruvic acid will be modified into acetyl-CoA in the presence of oxygen. Okay, that concludes the overview of cellular respiration.